we're going to talk about word problems, inequalities, and graphs. Let's kind of review from yesterday what we did. Can someone tell me the definition of an inequality? Everett.
Means equal to or not equal.
Okay, inequality means equal to, not equal to. What did we look at yesterday when we were determining if it was equal to or not equal to? Jack?
Number lines.
Number lines, okay? It did involve graphing from yesterday. What else did we do? Malachi?
We looked at the slide under the greater than or less than.
Okay, so we learned a new symbol yesterday, correct? We learned that we have, instead of just having less than and greater than, we learned that there is less than or equal to, greater than or equal to. Can someone tell me what less than or equal to means? Matt?
What? You're talking about like the symbol?
Well, yes, what does the symbol mean?
Okay. The symbol means it can either be less than, the symbol means it can either be equal to or less than.
It could be include that number or less than. Very good, that's good. Okay, what about greater than or equal to? Jillian?
It means like it can be that number or greater than.
So it can include that number or greater than that. And yesterday, I think someone said we did number lines. Jack said we did number lines. We graphed the inequality on a number line. What are the things that we look for when we are graphing an inequality on a number line? Leah?
If the symbol, if the greater than or less than symbol has a line under it, then the circle is closed. But if it's just normal,
Okay, so we looked at the symbol. And if it had a line underneath, then we knew that we had to include that number, so the circle was closed. If it did not have the line underneath, it meant it was just a symbol. It did not include the number, therefore the circle was open. What else? So let's look at our objective. We have to write an inequality to represent a condition in a real-world problem. So yesterday we looked at inequalities. Today we're going to write one. So if we go back to this opening slide, you're going to have to write an inequality like this. So I'm looking to make sure the variable is first, then the correct symbol, then the number we are comparing to. So that is how I expect your inequality to be written. It's going to represent. What's another word for represent that we use sometimes? Caleb?
To show.
To show. If you represent something,
Stand for.
to stand for. So to stand for a condition. Okay, we're going to come back to this word condition in a real world problem. So you're going to be given a real world scenario that you have to translate, and we've talked about the word translation before, what it means in math, that we're going to change it from the word form to the number form. Condition. I always like to talk about condition as in related to you. Do you get the condition at home that if you don't clean your room, you can't go to a friend's house, can't go to the mall, can't go to this, party, can't have your phone? That's a condition your mom has set for you, okay? Do you remember yesterday we talked about the amusement park and the rides? Yes? And the measurements, okay? And we said they usually have some little figure there that's got their hand sticking out that you got to kind of be underneath, be taller than that line. That's a condition. You have to be 4 foot or taller. So we're going to look at what condition, what statement is in the word problem. The next part of our lesson, we are going to translate real-world problems into inequalities. Remember the format that we're using. We're putting the variable, the inequality, and then what we're comparing our variable to. Remember we talked in the first objective that we're looking for a condition. These key phrases are going to be things such as at least, at most, more than, less than, greater than. You're going to see that those are the condition words that we have. We're always going to have an unknown. So let's take a moment to read what is on our slide. Bladen is at most 2 meters above sea level. What is the unknown? Jillian?
Where blatant is.
It's where blatant is for the C level. Okay? Do we know blatant's position for the C level? No, we do not. That's why we assign it a variable. One thing that's it's a key strategy when we are looking at our inequalities. We have to understand what the variable represents. You all know that there's going to be a variable in the inequality, but it's key that you understand what the variable represents. Do not get in the habit of just putting X first and then looking for a condition and then the number. Truly read. Think of this problem as a small mini plot. When we're talking about word problems, think of it as a small mini plot and see what's happening in the storyline. So blatant is at most 2 meters above sea level. So we do not know blatant's position, so we assign it a variable. We do know we are comparing it to 2. Now what we have to see is his position less than 2? Less than or equal to 2 meters? Is it greater than 2 meters? Is it greater than or equal to 2 meters? What is the condition that we have in this word problem? Madison Turner?
2 meters.
What's the condition that we have? Those key terms that tells us if it's going to be more or less or equal to or greater than. What do you see as the key term, the condition here, Madison?
At most.
At most. So identify at most. That condition is going to kind of dictate what the inequality is. So blatant is at most 2 meters. So what do you see as the storyline here, the plot? Lexi, what do you see going on?
That's like his highest.
That is his highest. So that means he could be where? If this is his highest, what are some possible solutions, some possible places for him to be in sea level? Is it possible for him to be 5 meters? No. Is it possible for him to be 0 meters at sea level? Yes. Is it possible for him to be negative 10 meters below sea level? Yes. So this has to be what? His position has to be,
Lower than 2.
it has to be less than 2. Because like Lexi said, 2 is his greatest distance. He's not any higher than that. The next question is it equal to? Is he equal to 2 meters? Blatant is at most 2 meters. Mia?
Said yes, because at most that could be like his maximum.
That could be his maximum, and that means that we include the 2. So what does the X represent again in this scenario? We're blatant's position. So the inequality is blatant is less than or equal to 2 meters above sea level. Do we have any questions about this inequality? So when we read this, we need to identify the unknown. What don't we know? We need to identify the condition, and we need to understand what we're comparing our unknown to. All right, the next part of our lesson is going to be about some teamwork. Together as a team, you're going to translate each real life situation, and you're going to graph the inequality. So what I want you to do together as a team, read it real quickly. One person at your table is the writer. The other 3 or 4 people at your table are the checkers. You check to make sure what they're writing is correct, and then we're going to stand up around the room. Please go now. please make sure you have the graph. The number line. When we say graph the inequality, we're looking for the inequality on a number line. When your table is ready, please get in the position. All right, so you have every team has their inequality and graph. Let's go ahead and show. Scan each board for me, please. And let's see. What is unknown? Someone please raise your hand. Tell me what is unknown in this situation. Beth.
How many touchdowns he actually scored?
How many touchdowns he actually scored? What are we comparing that to? Mia.
10 touchdowns.
The 10 touchdowns. We're comparing it to 10. What is the condition that we have in this situation? What is the condition that we have in this situation? Abigail.
Less than.
It is less than. So what John scored is less than 10. Okay, show me your boards. What you got? Just look at Diogenes. We good? Show the class for me, please. Is the graph going in the right direction?
No.
You did that.
Look, Mia?
Well, they got like the right statement, but then they did the arrow wrong. Like,
Think of your inequality as an arrow. It's leading you in that direction, so your line should actually go the other way. But they did do the correct inequality, and they did do the correct circle. Everett. Do we agree with Everett? Yes. Do we agree with Jillian?
Yes.
Beth?
Yes.
Leah?
Yes.
Okay, let's go back to Tavares. What does he have? How do you read this inequality right here? Aaliyah?
T is greater than 10.
And what did T represent?
Touchdowns.
The touchdowns that John scored, right? So Javaris is saying John's touchdowns is greater than 10. Is that what that reads up there? Is John's touchdowns greater than 10? So what should this group, Fatima? Does it say that John's touchdown is greater than 10? It says less than. So what should we actually do here? All right, to conclude our lesson today, we're going to do an exit ticket. In this exit ticket, I'm going to measure the 3 objectives. I'm going to determine if you can read a real-life situation and translate it into an inequality. I'm going to assess if you can take the inequality and make a graph from it. And then if you can, the third thing is for you to determine the solution set. If you will please get on exit ticket. I see that everybody has completed the exit ticket. Let's go back over our objectives for today. We're going to recognize that inequalities have infinite many solutions. As we read our inequalities, we need to begin to think of the possible solutions. Remember, we talked about that the condition in the real world problem will help determine the possible solutions. We have limits, so it can't be all real numbers, all numbers. It can only be certain ones based off the condition. The real world inequalities are talking about an unknown that we are comparing to a number, and we're looking at the condition. Tomorrow, we are going to continue this discussion of real world inequalities. I'll use the data that you just submitted with the exit ticket to form tomorrow's lesson.